more machines equals more problems. But it doesn't have to. Hey everyone, my name is Sam Ingbar. I'm a solutions architect here at Temporal Technologies, and today I'm going to talk to you about building headache-free distributed agents with Temporal and LangGraph. So let's start by taking a look at the experience that we get with LangGraph. I start developing an agent locally on my laptop. I use a checkpointer to save state of the agent to a local file system as it progresses. This is awesome, right? I'm going, if I close the process or I have a bug in my code, I can often, pick it back up and resume from the disk with no problems. This is great. If my laptop runs out of battery and it dies, I can charge the laptop, and then I can recover from the file and I can continue if I'm going, 300, 400 iterations through my agentic loop, and I don't want to lose all my progress. But this changes when we go into the cloud. I can't use my checkpointer to save state to the local file system because there is no local file system in the cloud. Or if there is, I can't rely on it because I could potentially lose my compute. What do I mean by that? Well, let's go back to our scenario. I've built this agent on my local laptop. I save information to the disk and I retrieve information from the disk to recover. I run into a problem. But if I drop that laptop into a river, now I have to buy a new laptop. I have to try to recover that file, but most likely I can't. I might need to hire a professional to go through the hard disk, and it's probably not worth it. But the same idea applies in the cloud when I have compute that is distributed, meaning, if my process fails on a computer over in this data center, it doesn't necessarily mean that I'm going to start my next retry on a computer that's, in the same data center right next to that machine with access to the same physical storage. And so I can't rely on it. So this leads us to a natural conclusion. More machines equals more problems. But it doesn't have to. These are some of the problems that we run into, right? We have local file system becoming a distributed file system. We have ports and local hosts moving into ALBs, DNS, certificates that need to be dealt with, authentication. We have one client to many clients, and we have to introduce this idea of a client session versus an agent session. Do I want to have a conversation with a continuous agentic session over multiple visits to the app, for example? And I need to be ready to deal with cloud outages, replicating my agentic activities midstream, and all the operations that come with that, which are not easy to do. But there is a better way. With Temporal, we automatically save and load workflow state as we progress through each step of that agent loop. It's persisted across multiple nodes in Temporal using Raft, meaning that even if one of them goes down, there's no risk of you losing your information. Temporal also allows you to test across multiple environments, meaning you can test in the cloud environment from your local machine with local code. You can then deploy the code and run it in the cloud once you know it's ready. And you can also test entirely locally with a local Temporal server before you even test in the cloud to shorten those development cycles. Temporal also handles a lot of the networking complexity that can come up. No need for queues, no need for state databases, no need for durability layers around those different tools. Temporal is going to take care of all of that for you. Temporal creates workflow executions that are natively long running, meaning that workflow execution can become your agentic session. Now you just need to build user sessions that can connect to various workflows, and you have your user session, agentic session constructs in place. And we support multi-region and multi-cloud replication to survive regional outages. So this sounds pretty perfect, right? We can also wrap our LangGraph applications with Temporal to give them those powers. And so the LangGraph application that we built can now survive crashes seamlessly and resume from the point of failure, even when we deploy it. We don't need to manage any kind of databases, do any networking, or deal with any other infrastructure concerns to make that happen. We maintain less code. We can do pretty much endless human in the loop without consuming resources when the agent is idle. And maybe if we're lucky, we can even vibe code a fix to the next cloud outage with multi-region replication. So this is awesome, right? Well, let's see it in action. Here we have a Temporal UI on the right, and on the left, we have a customer support agent. So I'm going to go ahead, I'm going to start with just a Temporal, or just a LangGraph standalone workflow and show some of their edge points here. I'm going to move myself as well over to here. So on our customer support agent, this is going to help us buy some music. I'm using this as an example of a very simple agent that's going to just illustrate some of the rough edges. If we pop into the demo controls, we can see that I have some controls that I'm going to use to introduce failures and things like that. But first, let's see how this works. I'm going to say hello. I'm just going to say, hi, what music can I help you find today? I'm going to say, I want to buy some rock and roll. It's going to say, great, we found these songs. What would you like to buy? I'm going to say, buy them all. We now have a human in the loop step. I'm going to say approve. And we complete the purchase. That worked brilliantly. But now let's introduce some failure. So I'm going to introduce some random OpenAI failures and see how that affects things. I also want some soul music. Now it's having trouble. Seems like that came back okay. Let's keep going and see if we run into some failures. I'll say buy the third one. This is a little interesting because it's saying there's 15 tracks, but we only see 2. So I'm going to say buy the third one and see what happens. Do we mean Mr. and Mrs. Jones by Amy Winehouse? I'm gonna now break this API and just let's see what happens. Yes. It's now stuck. And so we have a checkpointer set up, but we've had to set up a database to do it. And so if I turn this API back on now, and I hit resume, I now need to manually retrigger this run. So that means I either need to keep state in the front end of my application in order to do the retrigger, or I have to have some type of manual step by the user in order to retrigger this agent. So I'm going to hit approve. We're going to wrap up this LangGraph demo. You can kind of see that rough edge around checkpointing. The other piece is all of the silent work that I had to do to make this possible. I needed to stick it up a database. I needed to connect it with the pods that are running this application. And then I also need to, if I'm operating this in a real situation, I need to be ready to scale that database, operate that database, perform upgrades on that database. And I don't want my application to go down while I'm doing all that stuff, and that's not easy. So this is LangGraph. Let's now go back and let's see what does a LangGraph look like with temporal. So I'm going to start the conversation. We're going to have a similar conversation. We'll say, I want to buy some rock and roll. I'm going to refresh over here. You can see we now have improved visibility into what's happening. So here I can actually see this temporal workflow progressing. And we are using a workflow update to manage this request in to response back. And so you can see the send message update with information about each substep that we're operating and the inputs and outputs for each. So the requests and the outcome in this case. And this is a standard level of visibility we'll always get with temporal. And each of these green boxes, we're checkpointing the outcome so we can reconstruct the workflow without having to incur LLM costs if for some reason this crashes. I still have OpenAI, or I'm going to re-enable OpenAI random failures, and let's see if we hit some as we go here. So I'm going to say buy the third and fifth one. So we can again see this executing in real time. It's now jumped to a human in the loop step, and we can sit here indefinitely. And unlike in LangGraph, where this required some compute to be running the application waiting for this incoming message, temporal will maintain this workflow regardless of the state of my worker, which is running the application. And so even if I knock over my worker, which I can do here, so my worker is down, if I now hit approve, we can actually still send and receive this message. So when I turn this guy back on, you can see that it now just continues. So we can see we got the approved purchase signal here, and then it proceeds. That's not possible with LangGraph. Let's try a few more and see if we hit some failures. I'd love to show you what that looks like as well. So let's get some dubstep. Okay, and just like that, we hit a failure. I couldn't have planned it better. So you can see we're on attempt 3 here. So 3 of unlimited. This is durable execution in practice. We're now on to 5 of unlimited. Let's see what's going on. Do I need to turn that off? Okay, and it succeeded. So this required 5 retries. So we got no retries whatsoever, and then we got 5 in a row that were failed attempts on that random OpenAI failures, which is kind of funny. But you can see we just retried. We specify a retry policy in our code. And then the agent continues. I did not have to do any work to resume it because all the state of this whole process is captured by Temporal. And so we can resume it. We do not incur LLM costs to do it. And we go right back to the point of failure. So this is some of the benefits of using Temporal. We get the visibility. We get the improved human in the loop. We get better resumption and checkpointing and less engineering effort. Last thing I'll just touch on is that in order to implement this, it's very simple. We're just basically running our LangGraph application inside of a workflow. It's, less than 100 lines of code in total. Most of that's boilerplate. And so really encourage you guys to try this out. I think it makes a big difference in terms of the seamlessness of the experience and just makes your life simpler. If you have questions, let us know. We always love to hear from you. And thank you guys for listening to this little demo. I hope it's been helpful. Have a great day.